Hello, this is Nas from NB Network Lessons. Hope everyone's doing okay. Welcome. Welcome to all students around the world. Thank you for joining. My today's topic is under Advanced Calculus Lesson 57. We're going to talk about relative rate of growth. Rate of growth is really important and critical component if you're working in industry of where you have to make predictions. For example, in case of insurance companies, they can basically come up with the functions and say, okay, function of Los Angeles, and then come up with function of Houston, and then do a comparison between both and see which one reaches infinity higher, and then based on that they can set up insurance rates. Similarly, you can use that if you become a scientist. You can use those functions and see which function has better rate of growth and so forth. So without any further ado, let's go ahead and get started. I took the liberty of writing this already in board in interest of saving time. If you look right here, in this particular graph right here, this is y-axis, this is x-axis. I took the liberty and drew three graphs. The first one is y is equal to e over x. Second one is y is equal to 2x. And third one is y is equal to x squared. As you can see, these are shooting up. Y is equal to ex is approaching infinity faster. Then y is equal to 2x. And then y is equal to 2x function is approaching faster than y is equal to x squared. So that's what I meant when I said that insurance companies basically find out the graph by using functions and then predicting, okay, where are going to be more accidents? Is it Houston? Is it Los Angeles or whatever? And then based on that, they come up with their rates. Similarly, if you have x-axis and you have y-axis, you have a function of y is equal to natural log of x. You see that basically this function is pretty steady, right? Whereas y is equal to ex, boom, shooting up. So say for example, this is Mobile, Alabama, okay? So the accident rate in Mobile, Alabama is pretty consistent low. Whereas this right here is New York. As you can see, it's shooting up pretty fast towards infinity. So that's y is equal to e raised to power x. So hope this makes sense to you. So if you've got two functions, you have fx and gx, okay? And you have to find out which one shoots up faster towards infinity. You do limit x raised to approaching infinity, function of x over gx. Let's say x is equal to, this x is equal to a, and this g of x is equal to b, right? So this function of x, the one on the top, will grow faster if a is greater than b and b is greater than 0. So what I do is that I basically say, okay, x is equal to a, so I have a raised to power x, then I have b raised to power x, and x is approaching infinity. As you can see right here, my function on the top is going to reach to infinity faster than one on the bottom. Now, if these functions f of x and g of x grow at the same rate, then if you take the limit of that, okay, and you solve the problem using L'Hopital's rule, you should get a finite number. Number other than 0, other than infinity, you get a finite number, okay? Then that means that the rate of growth of both functions is same. It could be something like this. You know, you have this right here. So you've got this function right here. And then you have another function right here. So their rate of growth is pretty same right here, okay? Both of them are shooting towards infinity, but at the same rate. So that's what I mean when I say, you know, if you take the limit of this, fx over gx, you get a finite number. So hope this makes sense to you. I will come back and solve maybe one or two problems which would make more sense. Thank you so much for watching. You have a good day. Bye-bye.